All right, let's talk about one of the most frustrating things in software development, the phantom slowdown. You know the one I'm talking about, that performance bug that just vanishes the second you start looking for it. It's like chasing a ghost.
This is the question, isn't it? It's the one that keeps us up at night. A user sends a ticket. They're complaining about slowness, but you check the system and everything looks perfectly fine. It feels impossible to solve. Well, today we're going to put on our detective hats and crack this case wide open. So, here's our whole setup. We've got a user reporting that a specific API request is taking forever to load. But here's the kicker. It only happens once in a while. We've tried to make it happen ourselves, but of course for us, it's lightning fast every single time. Classic, right? So our mission today is to become performance detectives. We are not going to guess. We're not going to just start poking around randomly. Nope. We're going to use our observability tools to follow the digital breadcrumbs and find the real root cause once and for all.
You know, every good investigation has to start with a map of the crime scene. In our world, that's a service map. It gives us that all-important bird's-eye view of how all the different parts of our application are actually talking to each other.
Okay, so take a look here. This is our application on a perfectly normal day. You can see the API gateway getting requests. It passes them over to a Lambda function, which then goes and talks to our DynamoDB database. Everything's green, latencies are super low, error rates are at 0. I mean, this is basically a picture of perfect health. But the second we filter this view down to the exact time the user was complaining, the whole picture changes. I mean, look at this. The latency for the API gateway and the Lambda? Still low, totally fine. But the call to DynamoDB? It spikes to over 800 milliseconds. That right there, that's our hotspot. That is our first major clue. And this is just so key. The map itself doesn't just hand us the answer. But what it does, and this is crucial, is it acts like a giant blinking arrow. It tells us, hey, stop looking at the 99% of the system that's working just fine and focus your investigation right here. The search has just been narrowed way, way down. So now that we know where to look, we need to figure out exactly what happened. It's time to zoom in. We're going to go from that 30,000-foot view of the map all the way down to the granular moment-by-moment journey of one single slow request. Now, this timeline, this is what we call a distributed trace. And let me tell you, it's our smoking gun. It shows us the entire life of one request from start to finish. Let's walk through it. Okay, the request hits the API gateway. 50 milliseconds later, it invokes our Lambda. The Lambda starts doing its thing, and then, bam! Look at that huge gap. It's just sitting there waiting for over 800 milliseconds just to get a response back from DynamoDB. That is not normal. Okay, we've followed the trail, we've seen that crazy delay, and now it's time to confirm our number one suspect. We are closing in on the bottleneck.
And here it is, laid out plain as day. On the left, you've got a healthy request where that database read is a really snappy 45 milliseconds. But on the right, our problem request, that same read takes a whopping 810 milliseconds. Everything else is identical. That's it. We've found it.
The culprit is an inefficient database query. What's probably happening is it's scanning the entire table instead of using an index. For most searches, that's fine. But when a user searches for something that returns thousands of items, the whole thing just grinds to a halt. The fix? Simple. We add a proper index to the table, or we rewrite the query to be more efficient. Case closed. Now, solving one bug is great. But you know what's even better? Preventing hundreds of future bugs. So, let's take what we just did and turn it into a set of best practices that any team out there can use. So here's your takeaway handbook. Number 1, trace early. Start instrumenting your code for tracing before problems pop up. 2, sample smartly. You don't need to save every single trace. That's way too much data. Smart sampling lets you capture the weird ones, the outliers, without drowning your system. 3, add context. Tag your traces with useful info like user IDs so you can actually find them later. 4, drill down. Always follow the detective method. Start high with the map, then zoom into the specific traces. And finally, number 5, correlate your data. Traces, logs, metrics, they're all just clues. When you put them all together, that's when you get the full story. So, the final question I have for you is this. Your application, right now, is full of these invisible interactions and potential bottlenecks, just like the one we found today. Do you have the tools, the visibility you need to find that needle in the haystack when things inevitably go wrong?
Something to think about. Thanks for joining me.